Okay, in this video we're going to be talking about domain and range of partially bounded graphs, or in this case it's actually a function. So let's talk about the domain first. Remember that in the past couple of videos I've talked about the domain is the set of input values, or in other words all the possible x values of every coordinate. So like this function right here, this absolute value function, is consisted of multiple points. Okay, and each point is a coordinate, and it has some x value, some y value, some x value, some y value, and you just keep going, right? So as far as domain, we're basically asking, is there any x value, is there any coordinate point on this graph that wouldn't have an x value? Well, let's see. From what we can visually see, like what's actually physically here, we would have an x value from here, right? An x value here, and so on and so forth, right? Same thing the other direction. X value here, x value here. Anywhere there's a coordinate point, there's going to be an x value. Okay. Now, what the arrows mean is that it's going to continue on forever and ever and ever and always, and which means that the dots that I can make would continue on forever and ever and ever and ever and always, which means that the coordinate points would continue on forever and ever and ever and always, and I would continue to have x values for forever and ever and ever and ever and always. So basically what we would say is that we could either say it like so, that the x is an element of all reals. Okay, and you're looking for this sign. It's basically an R with a slash through it, a vertical slash. And let me rewrite this and kind of clean it up a little bit so it's easier to see. These markers are kind of fresh, so it's hard to write it to where it doesn't bleed everywhere. But whoever got me these markers, I really appreciate it, because these are awesome. I wouldn't be able to make these videos without these markers. So thank you very much. Okay, so let's talk about the range real quick. And so the range. Excuse me, before I get to the range, I forgot to talk about the other way you could write this. Well, since it's forever and ever and ever and always, we could write this in interval notation. Set notation. And it would be from the negative infinity, comma, positive infinity. And infinity is just it goes on forever and ever and ever and never has an ending point, which means you can't have a boundary on infinity and negative infinity. So we would use open brackets, or in other words, parentheses. Okay, so range. So we check out the range. That's all the y values, or in other words, is there a coordinate where we wouldn't have some y values? Okay, so like so we have all these coordinates here, and they kind of line up horizontally with the y-axis. And the same thing's over here. It lines up y-axis, and so it's basically saying what is the limitations on the y values. Okay. Well, if we look here, this is the bottommost point, and that is at 0, 1. Okay, which means that we can't have any values below that. And so our range would have to be from 1, right? It's the y values. And then since this continues on forever and ever and ever and always, it's going to be continuing in this diagonal, and we would be able to draw horizontal lines and find some kind of, because it's going to continue forever, find some kind of y value. So our range is from 1 to positive infinity, and we could write that as x is greater than or equal to 1. It's equal because it includes that point, that bottommost point. Or we could write it as 1, open this bracket here, comma, positive infinity, parentheses. And that would be the domain and range of that function.